Welcome. The purpose of this video is to go through the explanation for the math for Chapter 12, Inventory Management, Economic Order Quantity, Reorder Point. So in front of you is a summary of some of the terms that we talked about in class. At this point, it'd be a good idea to go through your text and fill out spaces on this. Of course, it'll be the same sorts of things on the take-home test. And then in order to check to make sure that you got this down well, it'd be a good idea to go through and work these discussion questions right here, because these discussion questions sort of go back over what it is here in the handout. With that, we're going to go jump right into the assumptions of the economic order quantity model and the key terms, and then the assumptions of the ROP and the key terms. And then we'll move into actually calculating some of the work with respect to economic order quantity and reorder point. So the first assumption of the economic order quantity model is that demand is known, constant, and independent. From there, the second assumption of the economic order quantity model is that lead time is known and consistent. Knowing these two things right away helps you see that this model is only going to work in particular situations. As well, inventory is received just as we order it, so it's instantaneous is what we say, and quantity discounts are not possible. And then it's also important to note that variable costs are only those associated with setting up the process or for placing the order. And the only holding costs are those related to storing the inventory over time. And then stockouts can be completely avoided if the orders are placed on time. So with those assumptions, the economic order quantity model, which is a minimization problem, so we'll write over here, EOQ model is a minimization problem where we're trying to minimize holding costs and ordering costs. So it's a minimization trying to minimize holding and ordering costs. So the key terms related to the economic order quantity model is D for annual demand, H for holding cost, and S for shipping costs. All right, so with that information, let's go to the next page. We'll come back and fill out the bottom there for the reorder point when we get to those. And we'll go on to the next page and we'll do some computations for economic order quantity. All right, so the first problem we're going to do here is a basic economic order quantity model. Here, we're trying to minimize the amount of money we spend on both ordering and shipping each year. So we have an annual demand of 1,000. So we'll note here that we have a big D equal to 1,000. We have ordering costs noted as S equal to $10. And we have holding costs, we're going to call H, equal to 50 cents. We note that the firm operates 250 days per year. And with that, we can go ahead and calculate several different things. So the first thing we want to calculate is going to be the economic order quantity. Which we'll do right here. EOQ will equal the square root of 2 times 1,000, that's our annual demand, times S, which is going to be 10, divided by H, which is 0.50. So this will yield the economic order quantity of 200. Which means that when we place an order, we should place an order for 200. So that's an important thing here. When we place an order, we want to place an order for 200. So I went ahead and wrote that down. Orders should be placed for 200 units at a time. Now next it says compute the number of orders, the time between orders, and the annual inventory holding cost. So we'll start with the first thing, the time between orders. So you look over here to the right and you notice that the time between orders is the formula right here, where we take the number of working days per year and we divide by the orders per year. But first we've got to calculate the number of orders per year, which is going to be this N right here. So we'll start there and then we'll move on to the next equation. So N, orders per year, will equal D divided by EOQ. So that's going to be annual demand divided by EOQ, which is just what we just computed. So we're going to have 1,000 divided by 200. And that means we're going to have 5 orders per year. So days between orders then are calculated as the total number of days, which is 250, divided by N, which is our 5 orders per year, which will give us 50 days between orders. Okay, so next we'll calculate the annual inventory and holding costs. So our annual holding cost will be calculated as, so our Q divided by 2, so our annual order quantity is 200. We divide that by 2, and we multiply them by H, which was 0.5. And then down here for our annual setup cost, we're just going to take our annual demand, which is 1,000, and divide that by Q, which is 200, and multiply that times our shipping cost, which we know is 10. And we then learn that this is 50, and this is 50. Thus, our total annual cost is going to be $100 because total annual cost is the combination of annual holding plus annual shipping cost. So it is Q over 2 times H plus D over Q times S, which is exactly what we just calculated above. So we end up with 50 plus 50 equals 100. And 100 is our total annual cost affiliated with inventory carrying. So what I want you to do is calculate on your own this when the demand doubles to 2,000. How does that affect the EOQ? So you get a chance here to review what we just did and calculate the EOQ model. So you're going to use the formula we just did. 2 times D times S divided by H. And we're going to look and compare what you get here with our EOQ that we got above. And then related to this are these homework problems. These are about economic order quantity. So go ahead and do that, and then when you're ready you can come back and watch the next video on quantity discounts. Hope this is helpful. Thanks. Bye.